The sun. Brilliant, powerful, giver of life. But this is the story of how the sun will one day become our enemy. If we are to survive, we'll have to leave the Earth. We'll need to seek out new homes in amazing new places. And change other worlds to recreate the Earth we left behind. In the far future, our sun will become a monster. It will burn all life from our planet, destroy entire worlds. And finally, our sun will even destroy itself.
It's going to happen. One day our sun will die, and when it does, we'll go with it. It's time to think about the future.
For 5 billion years, the sun has nourished the Earth. It is the sun that provides the energy for plants to grow. It is the sun that makes life on Earth possible. But that will change. Slowly, unstoppably, our sun is getting hotter and hotter. Once it gave life to us all, but what it gave, it can also take away.
If human beings are to have a long-term future, we must leave our planet behind and search for new places to live. One day, our homes will be out there, somewhere in space.
In the distant future, this could be our home. Out here in space, we'll have to seek refuge on new worlds where we could settle and live. The reason is, we have to escape from our sun. Some new worlds may be difficult to adapt to. Others may be very like our own. But what is it that makes our planet so special? And why is it so dependent on the sun?
Here is the sun as it is today.
In the center of our solar system. The Earth goes round it about there. There are the other planets.
The reason why our planet is the one with life on it is that it is just the right distance from the sun.
Closer in, and we'd boil. Further out, and we'd freeze. We live in a kind of safe zone that's perfect for life.
The trouble is that zone is moving. The sun is getting hotter, and as it does, the region where life can exist shifts further and further out. Ultimately, the safe zone will leave Earth behind. When it does, we'll be in serious trouble. Our planet will die.
This is how it will happen. As the sun burns up its nuclear energy, it will become hotter. In the far future, life on Earth will become impossible. And there's nothing we can do about it. What will happen to us then? Astronautical engineer Robert Zubrin believes he has the answer. He wants to find us a new place to live.
The only real choice that we have is to grow, expand, become a spacefaring civilization, or to become extinct. Not only would we become extinct, but unless we become a spacefaring civilization and bring Earth life out with us into the universe, all life on Earth will become extinct.
Robert Zubrin's goal is to make us a home on Mars. Today, Mars is cold and lifeless. Temperatures regularly drop to 100 below freezing, and its atmosphere is 200 times thinner than our own. A person standing unprotected on the surface of Mars would be dead in seconds. Yet some scientists believe we could still learn to call this home.
Mars is the only other planet in our solar system that has on it all the resources needed to support life. It has water. It's frozen to the surface as ice and permafrost, but it's there. It's got carbon dioxide in the atmosphere. It's got nitrogen in the atmosphere. And if humans go to Mars and develop the craft of how to use these resources, then we can make Mars a place where human beings can sustain themselves. We can make a new world for our posterity. No species can expect to last long if it stays in the same place. In a very real sense, humans are not native to the Earth. We're not native to North America. We're not even native to Europe. We're native to Kenya. That's why we're tropical animals with long, thin arms, no fur. But humans were able to leave there and colonize the Earth by becoming creative. Man the inventor. That's how we coped with Ice Age Europe, and that's how we're going to cope with Mars and the planets beyond.
In a remote part of Canada, researchers have already been preparing for life as pioneers on Mars. Living in a space pod did prove difficult, but they coped. Zubrin is optimistic.
We're ready to take this on. And frankly, if we shrink from this challenge, what it would really mean is that we have become much less than the kind of people we once were.
Ignition sequence start.
We are much better prepared today to send humans to Mars than we were to send people to the moon in 1961 when John F. Kennedy started the Apollo program.
I believe that this nation should commit itself to achieving the goal of landing a man on the moon and returning him safely to the Earth.
And we were there 8 years later.
The Eagle has landed.
There is nothing in this that is beyond our technology. It's just a question of showing a little bit of moxie.
For Zubrin, it's not the technology that's lacking, it's the will. But technology and willpower alone may not be enough. Just look at what we'd leave behind. This is our life support system. The plants that create oxygen, countless species of animal. How will we fare without them?
Our survival depends on the living things we share our planet with. The air we breathe, the food we eat, all this is created by other forms of life. If Mars is to be our home, it'll have to be home to all of this as well.
15 years ago, we thought we knew the answer. This is Biosphere 2. a huge glass dome covering 3 acres of Arizona desert, completely sealed off from the rest of the planet. The theory was that people could survive in it because the whole environment was self-sustaining. Trees would provide oxygen, artificial clouds and oceans would regulate the climate. But the experiment failed. Food rapidly ran short, extra air had to be pumped in. On Mars, that failure would have killed them all. If we're ever going to call the Red Planet our home, clearly something's going to have to change. And the easiest thing to change may be Mars itself. It's an idea called terraforming. The aim is to transform a whole planet from a place where we couldn't survive to one where we could. NASA scientist Chris McKay believes we could turn Mars into something surprisingly like Earth.
When we think about going into space, we tend to focus on humans. But in fact, it turns out that it's easier for plants and microorganisms to go to Mars first. They're going to be the first Martians.
In Death Valley in California, Chris McKay is seeking Earth's most hardy creatures. Creatures that might be able to survive on Mars.
That's our guys.
These green smears are algae, microscopic organisms that can thrive even in the harsh and variable climate of Death Valley.
You can see that.
And they could thrive on Mars too. Sucking in its thin and unbreathable atmosphere of carbon dioxide and pumping out oxygen in its place. Except at the moment, even the algae would find Mars deadly.
The first step to make Mars habitable even for the toughest little algae, is to warm it up a bit. Right now it's too cold and too dry for any type of life from Earth. Well, warming up a planet is something we know how to do. We're doing it on Earth. The pollution on Earth would be the medicine on Mars.
It's a strange twist. The best way to make Mars a place we could live may be to pollute it. Here's how it would work. First, a spacecraft has to drop off the pollution-creating machines. Machine's job is to suck up a mixture of Martian dust and atmosphere and process it into new chemicals. It then belches out these greenhouse gases to warm the planet and dark soot to soak up heat from the sun. If we send enough machines, over time, Mars will warm up enough to allow these algae to survive. And the algae will begin to give Mars an atmosphere of oxygen. But to speed the process up, we would need more efficient oxygen makers. And the best that we know are plants and trees.
The real goal to making Mars breathable is to get trees growing there. Those trees, those will be the ones that make the habitable world. And then things will really start happening. As the oxygen level built up, insects, maybe small animals, and eventually large animals, and maybe even humans, could then survive naturally.
We could change Mars.
If I were to lay out a time scale, I would say 50 years humans go to Mars, and soon thereafter the algae and the bacteria go to Mars. And then maybe 30 years later the trees go to Mars. And then the humans come back, but this time in a natural setting that's biologically suitable for them. And then we've learned how to become a life form that lives on 2 planets, not just humans, but all of life.
It's a bold and astonishing plan. If it works, we could turn Mars into a planet very much like Earth. But even Mars will not last forever. Even there, we could never escape the power of the sun.
As the sun keeps getting hotter, the safe zone for life moves further and further out.
This is Mars. Now Earth's dead, this is our home. Thanks to our terraforming, it looks a lot like Earth. And thanks to the hotter sun, it's now in the safe zone. The only trouble is, the sun is still getting hotter. Eventually, the safe zone will leave Mars behind as well. And with Mars dead, we're next. Once again, human beings will be looking for a new home. And once again, we'll have to move further away from our brightening sun. But the planets further out are impossibly hostile worlds. Gas giants like Jupiter and Saturn are not places we could ever hope to transform. If we're going to survive on these alien worlds, it won't be the planets we'll have to change. We may have to change ourselves. David Brin is a science fiction writer. He imagines future worlds for a living.
Well, it's a big universe out there, and the Earth is a very specialized environment. But we're not going to find many Earths out there. If we want to spread out into the galaxy, then we're going to have to adapt to the universe. It's not very easy for human beings to get accustomed to that idea because we're used to making the environment adapt to us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off!
As the sun becomes hotter, new worlds will warm into life. This is Europa, one of Jupiter's huge moons. We know it today as a frozen planet, airless, with a crust of iron-hard ice. But in the future, it will be something else entirely. The ice will have melted. Europa will have become an ocean world. After Mars, perhaps we'll come here and make this our new home. We could live in cities at the bottom of an alien sea. But David Brin thinks that in the end, a life behind glass may not be the solution.
Now we're thinking of going to other planets. At first we'll arrive in spacesuits, live in domes, bringing our earthly environment with us. But eventually, people will want to get out of those domes, and part of that will involve changing ourselves to fit into new environments.
Our ancestors evolved for life on Earth, but Brin thinks our descendants may redesign themselves for a future on other worlds.
Human beings have been wonderfully inventive in the last 20 million years, and yet other species have not been idle. Birds developed lungs which the air flows through from one side to the other, so all of the lungs are used. We only use about half of our lung capacity. If we were to just genetically engineer ourselves so that our lungs flowed through like those of birds, think of the thin atmospheres that we could live in. Wouldn't it be great to be able to hibernate like a bear? We'd be able to travel to far planets, possibly even far stars. And if they live and work in zero gravity, eventually they're going to get sick and tired of pulling around a third of their weight in these useless legs, which are only good occasionally for pushing it against walls. Why have legs if you're in zero gravity, when you could have 2 additional arms? Wouldn't it be more functional, jumping all over the place like gibbons? Can genetic engineering achieve any of these things? Who knows? We're just at the beginning of this grand adventure. But it's an extravagant version of tomorrow that we should be thinking about. Wouldn't it be a desirable thing? If they're happy, if they're creative, if they're productive, if they're part of a great civilization. Vive la différence.
We can only guess at the future. What will our descendants be like? We'll have to wait and see. And where will they live? Because the only certainty is it cannot possibly be here. It's not just that the sun will have seared all life from planet Earth. It's that the planet itself will no longer exist. Everything we know will have disappeared. Because in the far future, our sun will turn into a monster. It's going to consume the solar system. Its first victim is the closest planet, Mercury. Next, Venus is transformed into a molten fireball. And ultimately, boiled away. And still the sun grows. It's 160 times its original size, 2,000 times hotter. And its next victim is the Earth. Long since seared barren by the sun, the place we once called home now melts and is engulfed. 7 billion years from now, the Earth will be gone. For us today, one question remains. Is the future of our planet also our future? Can we really survive the death of planet Earth?
Look at where we stand today. Look at how far we've come. Compared to the world of 100 years ago, we're living in a science fiction universe with skyscrapers 100 stories tall. Who can believe, looking at that looking forward to the next 100 years, there will not be a new branch of human civilization on Mars? And look back 1,000 years now. The world lit only by fire. Who can say that 1,000 years from now, there will not be hundreds of new branches of human civilization filling out worlds orbiting hundreds of stars in this neck of the galaxy? Some people think that we're living at the end of history. But I couldn't disagree more. I think we're living at the beginning of time. We're present at the creation. It's a glorious time to live.
For all we know, we might be the only life form in the galaxy and the universe. If that's true, I think that really deepens the importance of the role of humans in spreading life beyond the Earth. If we're the only spark of life, then we certainly don't want that spark to go out.
Our scientists today are already imagining strange and far-off tomorrows for our kind. And if we do survive, perhaps we will be there to witness the moment when our sun's transformations finally end. It was first the giver of life, then the destroyer of worlds. And now, it too is doomed.
This is the sun at the end of its life. Layer after layer, it is blowing itself apart. Huge clouds of star stuff drift out into space. It's a slow process, it takes millions of years, and what follows is inevitable: the death of our sun.
It casts off one final layer, and its spark is extinguished forever.
So the sun will one day go out. Will that be a significant event to our descendants billions of years hence? I don't think so. They will have observed a similar phenomenon on innumerable other stars long before that time. But if they did think about it, they would note with gratitude that their ancestors did not stay on that one little world and await their doom, but rather spread forth into the universe and made their life possible.
No one can know our future, but our sun's future is certain. There will come a time when we must leave our Earth behind. Our planet will be gone. Our home will be in space.
– 2017 was a busy year for scientists of all sorts, the professional and the enthusiast alike. From a predictable astronomical rarity to surprise discoveries deep underground. It was a year that saw long-held beliefs challenged by newly found wonders, breakthroughs that led to innovations, and a glimpse 130 million years into the past. In August 2017, alarms sounded at the most sensitive scientific devices ever constructed. In Washington State, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected faint disturbances from deep space. The signal also hit LIGO's sister facility in Louisiana. Gravitational waves had reached Earth.
Gravitational waves are ripples in space-time. Space-time is incredibly dense. So to cause ripples, you have to have some sort of object that has enormous gravity, like a black hole or a neutron star. And when these objects are rapidly accelerating, they bend space-time and create these ripples that then travel through the universe to our detectors on Earth. Like the one last August.
On high alert, the LIGO team quickly reached out to Virgo, its European counterpart in Italy, who confirmed that they too had detected gravitational waves. And then, as if by destiny, the stars would align once more to pave the way to a groundbreaking discovery.
Just 2 seconds later, with the Fermi Gamma Ray Space Telescope, we detected a short, bright flash of high-energy light that we call a gamma ray burst. This alerted the entire astronomical community to the fact that something very exciting was happening.
Using data collected from LIGO, Virgo, and Fermi, 70 ground and space-based telescopes scoured the edge of galaxy NGC 4993, some 130 million light-years away from Earth, searching for a small flash of light amidst a sea of stars. It would take less than 12 hours after the alarms rang at LIGO for Earth to have visual confirmation of a never-before-seen astronomical event.
What we saw was the result of the merging of 2 neutron stars. When they merged, they created an explosion in space-time. Those ripples went out across the universe as gravitational waves and were detected on Earth. The matter involved gave off gamma rays and other forms of light.
Neutron stars are the collapsed cores of massive stars left behind after a supernova explosion. No larger than a mid-sized city, these dense stars have 10 to 60% more mass than our Sun. This pair of stars, 200 miles apart, were locked in each other's orbit for over 11 billion years. But as they started accelerating and moving inwards, their orbit quickened from 30 times a second to an astonishing and unsustainable 2,000 orbits a second. Then, 130 million years ago, they collided in a resounding explosion. Peering into the past, telescopes were able to see the remnants of one of the universe's most impressive fireworks shows. A bright flash of blue followed the initial explosion, growing redder and duller as the days passed, until eventually fading to black.
The conditions around these merging neutron stars have densities and temperatures completely unlike anything we can do on Earth.
The violent explosion was observed to have produced 200 Earth masses worth of gold and 500 Earth masses of platinum, revealing for the first time the origins of heavy metals in our galaxy.
We think that all the gold in the universe was formed in explosions of this kind. After the explosion happens, the gold is spread out into the gas and dust of the interstellar medium. Later on, that gas and dust collapses into brand new stars and brand new planetary systems.
And these weren't the first gravitational waves detected by LIGO this year. 2 separate events have been measured before, including a pair of monstrous black holes that collided to form a single spinning hole 53 times more massive than the Sun.
We received a perfect signal from this last merger. It traveled 3 billion light years to get here. In any given galaxy, one of these events might only happen once every million years, but we're now able to monitor about 10 million galaxies at a time. It's a new type of astronomy.
But while we wait for gravitational waves that can open a window on the origins of our universe, volcanic activity off the coast of Japan is presenting scientists with a picture of Earth's early history, when land first rose from the seas. Violent eruptions spew a steady stream of lava and rocks, expanding the newly emerged island of Nishinoshima 3 square kilometers in just 5 short months this year. These most recent blasts stopped in August, but could resume at any time. Situated atop the junction of 4 tectonic plates, the Japanese islands offer stunning insights about the formation of a variety of landscapes. Analysis of Nishinoshima's magma shows it to be andesitic, similar to the composition of continental crust. Monitoring the growth of Nishinoshima, geologists hope to learn more about the forces that led to the birth of the world's 8 continents. Yes, not 7, 8. In February 2017, the Geological Society of America published a startling paper. Zealandia, Earth's hidden continent. Geologist Nick Mortimer was the lead author.
To discover Zealandia is to change the map of the world, quite literally. Beforehand, most people would say, yes, we got 7 continents, they could count them off. But now, the world map's changed and we've got an 8th one on there.
In the beginning, there was no search for Zealandia. Mortimer and his team discovered the shallow submerged continent while performing geological work aboard a research vessel off of New Zealand's coast.
And so what the various geological investigations have led us to is that we do have the components of a continent here. When you pull the plug on the world's oceans, you literally reveal the continent of Zealandia.
Mortimer and his team confirmed 4 geological markers, the qualifying criteria for a continent. Height, a varied geology or diversity of rock types, a thick crust, and ultimately size. Is it big enough? Corroborating data include rock samples, ocean drill cores, and satellite microgravity measurements, translated into bathymetric or elevation maps of the sea floor. Situated between the Pacific Plate and the Australian Plate, tectonic forces squeezed Zealandia, raising out of the water what we know today as New Zealand. With 94% of Zealandia underwater, the islands of New Zealand and New Caledonia are just the tip of this continental iceberg. And measuring in at 4.9 million square kilometers, Zealandia is 6 times bigger than the so-called microcontinent of Madagascar, and more than twice as large as Greenland, which also happens to be attached to North America. To understand Zealandia's origins, we must travel back in time to the time of the supercontinent Gondwana, comprised of what we know today as Africa, South America, Antarctica, and Australia. When Gondwana split apart 80 million years ago, it was a bit like the stretching of bread dough in a kitchen.
And then you start to pull that big lump of dough apart. And if you pull slowly, some of those pieces will stretch and get thinner.
Just like Zealandia, which broke off and slowly sank because of its relatively thin continental crust.
It's not as thick as the main continents, but it is thicker than the ocean crust. And geophysicists know that when you have thin crust, it floats lower in the mantle, and so it sits lower elevation-wise, and that explains, in very simple terms, why Zealandia is so submerged. Now that we've got Zealandia in the scientific arena, we do hope to consolidate it and to promote Zealandia in New Zealand schools, first of all, and we hope to get it in atlases, on globes. We hope that Zealandia will become as common and well known as any of the other major continents.
Of course, the initial buzz about Zealandia can only help its name recognition.
The notion that something so big and so important could be hidden for so long, I think captured people's imagination.
Out of sight, out of mind, no more. Of course, not everything that's undetected is so obviously obscured. And one remarkable discovery this year offers clues about how some prehistoric creatures could hide in plain sight. In northern Alberta, Canada, the remnants of a 110-million-year-old dinosaur from the late Mesozoic era is providing the world with an unprecedented look at a new species, the nodosaur. A fossil so pristine and complete that it shows the texture, patterns, and color of a prehistoric giant.
The nodosaur is the best specimen we have, and it's the closest you'll come, until we find a better one, in terms of coming face to face with a dinosaur.
The nodosaur is next to surreal. A petrified beast caught by Medusa's gaze.
We knew it was good, but we didn't know how good it was. I think it's the best preserved armored dinosaur in the world. I'm calling this the Rosetta Stone for armored dinosaurs.
The anatomy of the new species has already given scientists clues to how these animals evolved, how they radiated and diversified through time. And it doesn't stop there.
The skin is preserved. It's not just the impression of the skin. We actually have some of the original biomolecules preserved. One of the cool things that they tell us for this specimen.
With the continual issue of climate change and sea level rise, we're seeing an increase of water level every year. We had to make changes to adapt to this future condition. What you're seeing here, we put a boardwalk initially to give some height, but we found that that wasn't protecting the city. What we've done here is we've increased the levels of our new seawall. The new wall you see in the background here is our new standards. This is good for approximately another 50 years, and we're going to see water levels challenging even that new seawall.
Raising its elevation, Miami Beach seeks to stay dry and take control of its future.
The city's philosophy, our culture, is rising above. We believe that we can meet the challenge. And the challenge is not only in rising above, meaning elevation, it's rising to and withstanding the challenges that come with sea level rise due to climate change. As a city engineer, I have complete faith that we can win. We can mitigate. We can survive.
Of course, the Earth's oceans have risen and fallen many times during the planet's history. And new archaeological evidence suggests these shifting shorelines may conceal clues about the earliest Americans. Until just recently, archaeologists generally agreed that the earliest people to populate North America were the Clovis people, dating back to some 12 to 13,000 years ago. But a group of scientists in San Diego, California, have a different theory.
We have the bones, the fossils, the distribution, the rocks, the date. We have evidence for humans in North America 130,000 years ago. We realize that that is a startling claim.
But the scientific community is struggling with the idea that humans arrived in North America 130,000 years ago.
The study of early humans in the New World has been very political and very controversial for over 125 years.
It's an old mystery yet to be solved, deciding who got to North America first and when.
Welcome, and thank you for joining us this morning at the San Diego Natural History Museum as we share some exciting news about a discovery made right here in San Diego.
Well, back in 1992, Caltrans was doing improvements to State Route 54, which involved adding a couple new travel lanes. And Richard Cerruti, who's a field paleontologist here at the museum, was monitoring the excavations on the very north side of the freeway alignment and saw this little puff of let's say, tusk material being scraped up by an excavator and said, "Stop, let me go look at this."
The bones that Richard Cerruti found belonged to an ancient mastodon.
That's one tooth, and it's characteristic of American mastodon.
Were these giants sharing North America with early man 130,000 years ago? The answer may lie in the position of the bones and tools found at the site.
There are anomalous fragments of rock, anomalous fragments of tooth enamel scattered throughout the site that just don't make sense.
Could these stones amongst ancient bone remnants have been an early form of primitive tools?
And we felt that it was important to produce a map where we carefully plotted or precisely plotted the position of all the bones and the stones or whatever else is in there, so that we can understand what the general pattern is.
it's thought that the tools found with the mastodon bones were used for butchering the animal.
So this is one of the cobbles that we hypothesized was used as a hammerstone. 130,000 years ago, where there was a carcass of a mastodon. These people were trying to recover raw materials from it. They had a problem. How do we break these bones? They look over into the active river channel, find some cobbles of the appropriate size and weight, bring them back to the site. And if you look closely, there's some striations coming off of that are indications of where this flake has come off.
The cuts in this rock led the San Diego team to conclude that these were actually tools used by humans. An idea that Demir says might not be so far-fetched. Dr. Stephen Holin is co-director of the Center for American Paleolithic Research in South Dakota. He was part of the team that evaluated the findings from the San Diego excavation site.
So what do we got in here, Steve?
Looks like vertebra.
It does.
I said, I can't get my mind around this. This site has to be really, really old, but yet here's evidence of humans. I said it goes against everything I thought I knew and everything I have ever been taught.
Holin evaluated the mastodon bones and the stone tools recovered from the excavation site.
We would take the drawers out of the cabinets in here and bring them in on this table and look through them, paleontologists and archaeologists together. Richard Cerruti came in, so there were 4 of us, my wife Kathleen, Tom, and I, and we would look through and we would look for these very diagnostic pieces. And one of the things that we got all excited about first were these cone flakes that form in a circle around the point of impact from the hammerstone. And based on the experiment that we'd done in Africa, breaking an elephant femur with a big hammer, we saw the same kinds of fracture patterns that we did experimentally.
Holin specializes in evaluating broken bones at archaeological sites, looking for human causes, as this video shows from a test he conducted in Africa 2 years prior to working on the San Diego project.
Oh my God.
As we puzzled over this, we kept coming back to this one explanation that explains all the data, was that humans did this.
The detective work by the San Diego Natural History Museum team was capped by the age dating that Richard Cerruti had done to prove the age of the mastodon bones he discovered.
This is one of the specimens that he used in his analysis. He cored it and he also sliced it. And after analyzing over 100 microsamples from this specimen and 2 other specimens of bone from the site, yielded an age of 130,000 plus or minus 9,000.
So after the article came out, there has been no critic come out to say that the dating is incorrect. In fact, other specialists in uranium series dating have come out and said the dates look perfectly good. So we're very comfortable with the dates.
While humans' arrival in the Americas may have occurred earlier than previously thought, new dating of another paleontological find, found in a South African cave, could soon upend long-held theories about the evolutionary tree of primates and early humans.
When we actually got into the chamber and could start removing it, we realized that not only was there one individual lying there on the surface, but the floor was literally comprised of Homo naledi. There are thousands and thousands and thousands of remains down in those chambers, and all you have to do is sweep the surface off, and there they are.
So the first time I sort of slid through that hallway into the open area where the chamber is and sort of started looking around, you know, you're only wearing a headlamp, so you just see flashes, but every flash of my headlamp showed bone. So I think right at that point, I realized that we had a lot more than the original photographs actually had portrayed. So that was pretty exciting.
Homo naledi isn't really similar to any known hominid species in its entirety of its package. You've got little bits and pieces of almost everything we've ever found. Parts of the skull, if you just look at it quickly, look a little bit like Homo erectus. Got a very small brain. Other parts of the skull look very modern, like Homo sapiens. It gets stranger and stranger as you move down the body. You get the ape-like shoulders. You get these more and more human-like arms, which end with a hand that's human proportion.
I was actually at the London Natural History Museum, and Homo naledi was on the wall, and then there was estimated age between 1.2 and 1.8 million years. But then, when we actually did the scientific dating of those teeth, this is when things got very interesting, because then we got an age of 200 to 300,000 years old.
When we got a date, it was much younger than that, 250,000 years, give or take, we realized that we were dealing with a primitive creature, almost like a time traveler, that had come down from deep times to a point where it is very possible that Homo naledi was in direct contact with the emergence of modern humans. We never thought that was possible in Africa. Until this moment, we thought that there was effectively, during that entire time period of the Middle Pleistocene, late Middle Pleistocene, one form, a big-brained form of Homo sapiens. Now there are two, and that adds incredible complexity to our record.
The world of Homo naledi and other early humans was different than it is today. A veritable Garden of Eden, teeming with life, pure and free from pollution. Few places like this still exist, and most of them quite remote. But look just a few feet underwater, and you can find one of the most productive and overlooked ecosystems on Earth. Scientists recently learned that seagrass meadows help scrub the surrounding water clean of bacteria from raw sewage and other pathogens. A recent study of polluted waters in Indonesia showed levels of harmful bacteria to be 50% less in spots with robust seagrass beds, leading to healthier fish and coral in the surrounding area. You see, seagrasses oxygenate the water, trap sediment that might otherwise float freely, and host tiny microbes that kill many harmful bacteria. Eliminating toxins improves the health of any system, and the workings of a human body is no different. In athletics, though, they say no pain, no gain. A nod to the physical effort required to increase endurance and enjoy the health benefits of exercise. But new pharmaceutical research also aims to make those benefits more easily accessible.
The potential benefit of a drug that can tune you up in the way in which you normally get tuned up by exercise could have really dramatic effects.
Playfully known as the exercise pill, the experimental drug shifts metabolism by triggering genetic instructions for the body to burn fat instead of sugar during exercise, something that doesn't normally happen until after extensive training and conditioning. Recent tests increase the endurance of otherwise sedentary mice, which also proved to be resistant to weight gain while on the drug.
We have two groups of mice, and one group on the drug, the other group as a control without the treatment of the drug. So we were quite surprised to see the astonishing results. The mice treated with the drug, they can run almost 100 minutes longer than the one that are not treated. The increase was around 70%.
Researchers ultimately hope their product can improve the health of the disabled, elderly, and obese.
There are many reasons why people can't either walk or run or exercise. And the idea is if you can bring a small molecule into the picture that can confer the benefits of fitness without training, you could really help a lot of people.
From energizing our bodies to powering societies.
So we are just waiting for the next experiment. It's going to happen in 10 seconds. There you go. You see the flickering of the plasma? We are creating fusion here. This is our little sun. It's extremely hot.
Each day, every 20 minutes, researchers build the sun. At the Culham Fusion Centre in Oxfordshire, Britain, generating temperatures greater than 200 million degrees, these nuclear fusion trials would be impossible without JET, the Joint European Torus, a donut-shaped plasma containment vessel.
At this point, we're the most important experiment in the world.
Thanks to JET, where energy is created by combining hydrogen atoms.
Right? There's heavy hydrogen, which we call deuterium, and the super heavy hydrogen, which we call tritium. And when they're running around at these temperatures like 200 million degrees, they bang into each other with immense speed. And when they do, and they get close enough, what we call the strong force, which binds the nucleus of atoms together, grips them, pulls them together, and they fuse, and they make helium, and they spit out a neutron. Fusion really is the perfect way to make energy.
And yet, despite fusion's transformative potential to provide safe and sustainable energy to the world, the program faces an uncertain future. While the British government committed to pay for its share of the experiments up to the year 2020, Brexit, its planned departure from the European Union, may also lead to the UK's withdrawal from scientific agencies like Euratom, the European Atomic Energy Community. Some say this could jeopardize jet logistics and operations, and perhaps also the larger next-generation fusion experiment, currently being built in southern France. If fusion represents harnessing the physical power of the sun, a moment of darkness reflected its emotional power. An awe-induced euphoria experienced by millions as the first total solar eclipse over North America in 3 decades made its way across the United States.
It's the most unnatural natural phenomenon I ever saw.
This is a solar eclipse, and just what people witnessed on August 21st along a 70-mile wide path. First along the Oregon coast at 10:15 a.m. Pacific Daylight Time, and last in South Carolina 94 minutes later. The uncommon coupling was the most viewed and photographed eclipse ever recorded. And yet, even as the sun re-emerged from the moon's shadow, some earthly domains remained, as always, far removed from its rays. Like the cave chambers, 300 meters below Mexico's Nica mine. Enormous, razor-sharp crystals dwarf human explorers. While today the cave is totally submerged, previous expeditions collected bizarre life forms from these crystal giants. They call this place Hell on Earth. Temperatures climb to 135 degrees Fahrenheit, with over 80% humidity. Even with life-saving bodysuits, no visit can safely last longer than a half hour. Yet deep within this extreme environment are life forms which exist nowhere else, known as extremophiles. NASA astrobiologist Penny Boston and her team found 40 strains of mineral-eating organisms. Trapped within the crystals here, they collected sample microbes, some dormant, but alive, estimated to be between 10 and 50,000 years old, including genetically unique and previously undiscovered life forms.
Any extremophile system that we're studying actually, allows us to push the envelope of life further. And we add it to this atlas of possibilities that we can apply.
The first time we're looking inside of Jupiter with into the interior, and what we're seeing is that it doesn't work at all like we had predicted. Almost every model that has the interior motion, how the magnetic field, the gravity field, how the deep atmosphere works, it's all different.
Current modeling estimates that the cloud cover is roughly 30 miles thick. Below it, there lies a 13,000-mile layer of swirling hydrogen and helium that changes states from gas to liquid as it nears the center, leading to a 24,000-mile deep sea of metallic hydrogen.
If we can probe it and work out the abundance of elements in it, hydrogen, helium, the higher elements as well, and work out roughly what that mix is, it'll tell us something about not only how Jupiter was formed, but how the solar system might form.
If there is a bunch of rocky material in the center of Jupiter, it means that in the early solar system, before Jupiter formed, that rocky substances were probably coming together and Jupiter got built around those. It could be that Jupiter was built without any of those and that it just collapsed sort of like the sun and there is no rocky material or core of heavy elements in the center.
Strangely, though, gravity data collected so far points to a new possibility. A somewhat larger than previously thought and perhaps partially dissolved core, leaving Jupiter experts with more questions than answers.
We're putting the pieces of the puzzle together, and it's exciting, but we don't have the whole picture yet.
Juno's primary mission is scheduled to continue until February 2018. But this past year, NASA saw another of its extraordinary explorers come to the end.
And we are in the atmosphere.
As the Cassini space probe plummeted into Saturn's atmosphere in a fiery death spiral.
Roughly 1 minute to loss of signal.
The culmination of the craft's revolutionary scientific quest.
Call loss of signal at 115546.
The signal from the spacecraft is gone. Congratulations to you all. This has been an incredible spacecraft, and you're all an incredible team.
She has rewritten the textbooks about Saturn, the rings, the moons, Titan. So many things have changed because of Cassini.
From its launch 20 years ago to its bold grand finale, the Cassini-Huygens mission has unveiled some amazing discoveries. Saturn is ablaze with storms of unimaginable force. The place crackled with giant lightning strikes.